Now, on the next example, look at the placement of the half this time. Now it's not in front of the function, it's inside the function, together with x. So now here, this 1/2 affects the x values, versus before it affected the y values. So let's see what happens. Yeah, it'll do something to it, yes. Now I'm going to choose some values here. Okay, so these are the values we're going to use. Just trust me for now, okay? So make a table of values. The values we're going to choose for, and this is going to be for y equals sine of 1/2 x. So we're going to choose 0, pi, 2 pi, 3 pi, 4 pi. We already know from before, like if we had to, we could look at the table for the regular graph. And 0, pi over 2, pi, 3 pi over 2, 2 pi. For the regular sine curve, what's the sine of 0? 0, sine of pi over 2, 0, -1, 0. Okay, let's plot that one first. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. All right. Now, for the other one. So first, I have to take the sine of 1/2 times 0. But a half times 0 is still 0, right? So the sine of 0, that's going to be 0 still. All right. If I plug in pi, it'll be 1/2 of pi. 1/2 of pi is just pi over 2. So sine of pi over 2, that would be 1. Okay. If I plug in 2 pi, I get 1/2 of 2 pi. But 1/2 of 2 pi would just be pi. The sine of pi is 0. A half of 3 pi is 3 pi over 2. Sine of 3 pi over 2? -1, you see right there. And then last but not least, sine of 1/2 2 pi, or 4 pi. That would be 2 pi. Sine of 2 pi is 0. Okay. All right, go ahead and plot those points. Zero, 0, pi 1, two pi 0, 3 pi -1, and that should be 4 pi over there on the edge. And that should be 0. Connecting, we get that. So, what happened? Did the amplitude change? No, right? The values of sine didn't change. They still went between -1 and 1. What changed this time is the period, right? Okay. And if you think about it, it kind of makes sense. If we look back at our number, what we did here, this 1/2 slows me down. It slows down how we're going through those x values from 0 to 2 pi. We're going through it half as fast. So it stretches out, right, the length or the time it takes to get through that cycle, which makes my graph look longer, right? Stretches out the period. Okay. So it takes us twice as long to complete a cycle. If it were 2x instead of half x, then we would go through the cycle faster, right? So instead of it taking 0 to 2 pi, it would be half that, right? Because we're going through it twice as fast. So we would complete the cycle faster. So instead, we probably would see one cycle between 0 and pi instead if it were a 2x instead.